Okay, in this question, we have three plates. One of them is the first one is at 0 volt, and the second and the third plates are held at plus V volts. So we have electrons coming in here, exiting here. So what's the relationship between V1 and V3? We are going to apply the principle of conservation of energy. There are two ways to do it. The first way is to simply state that the KE and the EPE at the beginning, so at P1, should be equals to the KE and the EPE of the electron when it's at P3. So the KE when it's at P1, we can write it as half mv1 square. So m is the mass of the electron. The EPE when it's at P1, so EP is given by Q times V, right? So, but the thing to note is the charge of the electron should be written as negative E, because the charge of the electron should be negative 1.6 times 10 to the power of negative 19 coulombs. So the charge is negative E times the potential here, which is 0. So actually the EP of the electron when it's at P1 is 0, because the potential here is 0 volts. So the KE when it's at P3 is going to be half mv3 square. And the EPE when it's here, again, we are going to do Q times V, charge times the potential. So its charge is negative E, and the potential here is V. Alright. So rearrange the equation, pull the EV to one side, and then you have half m V3 square minus V1 square. So that is the first way of applying the principle of conservation of energy. Some students will prefer another way. I don't really like the other way, but I'll show it to you as well. So the gain in KE is the loss in EPE. To do this, you must first figure out that it's actually a gain in KE. And to do that, you should notice that this is at a higher potential than here. So there's going to be an E field directed towards the left. And because you are electron, you are going to experience a force that's in opposite direction to the E field. So the electric force experienced by the electron is going to be rightward. So between these two plates, you realize that it's going to experience an electric force that's going to accelerate it. Okay? Between these two plates, there's actually no electric field because there's no potential difference between these two plates here. So from this, we figure out that it's actually a gain in KE, which means that the electron must be losing EPE as it travels from here to here. Between here and here, there's no gain or loss of EPE because there's no potential difference between these two plates. Okay, so if you know there is a gain in KE, then you know that you should take the final KE minus away the initial KE. So you are going to do half mv3 square minus half mv1 square, and not the other way around, because when you set up the principle of conservation of energy this way, gain equals to loss, you need both sides to be a positive number. So you need to always take the bigger number to minus the smaller number so that you get a positive number. The loss in EP, for that we're going to do Q times delta V, so charge times the potential difference. Again, we want a positive number here, so all I'm going to do is I'm going to put down the charge of the electron, ignoring the sign, and the potential difference between them is simply V3. Oh, sorry, it is V, the potential is V, there's no V3. So yep, this is the same expression as this one. So either way, if you do it this way, then when you put in the charge and the potentials, make sure you put in make it a, if it's a negative charge, make sure you put in the negative sign here. If it's a negative potential, make sure you put in the negative potential here. If you are doing it this way, then you got to make sure both sides is a positive number. So for the loss in EP, I'm just going to put all the positive numbers here. I'll just strip away all the negative signs. But for this one, you got to be careful. You got to arrange the numbers such that it's a positive number. Pros and cons in either methods, so you choose the one that you like.